There are lots of different ways to solve quadratic equations and find the answers. The ones that we have covered so far are solving by factoring, solving using the quadratic formula. Soon we're going to be solving with graphing and even using the graphing calculator, but there are a couple of other methods that if we were in school, we would clearly be having more time together, and I would have taught you these as well. I'm not terribly worried about not having taught them in Algebra 1 because you will get them in either geometry or Algebra 2, but I'm going to kind of put it out there because some of us are kind of ready for learning a little bit more. But I'm just going to do these quickly. It was like a little extra footage in case you wanted to learn something new because you were bored. So I got you covered. Here's this equation here. It's a simple little equation, and we're going to solve it by factoring. If I were to solve this guy here by factoring, slide him up. Then two sets of parentheses, x in the beginning of each. Remember, there's nothing common. So first thing you have to do is a GCF. There are two terms with a minus sign. So it's difference of squares. Square root of the back, 4 and 4, plus and minus is equal to 0. So opposite would be your answers, -4 and +4. These are your solutions. If you can factor a quadratic equation, it's the fastest, easiest way to come up with the solutions. Not everything can be factored, which is why we have the other methods also. But notice we're using the same equation, so you know what? You're going to get the same answers. Quadratic formula. A equals B equals C equals 1, 0, -16. So x is equal to -b, 0, plus and minus the square root of b squared, minus 4 times a times c, -16, all over 2 times a. X is equal to 0. You know what? If you're not adding or subtracting anything, you don't need to have a number there. So it is going to be plus or minus. Negative, this is a -16. Negative times a negative is positive, and 4 times 16 is 64. Times 1 is also 64 over 2. Plus and minus, the square root of 64, by the way, is 8. 8 over 2 reduces to plus and minus 4. So positive and -4, which you can clump together like this, or you can break them up and write them separately. Here's another method. And this one here, taking the square root of both sides, we can only use when there's no middle term. So here we have no x term, so we can solve this equation by taking the square root of both sides. So we're going to keep the x squared on the left, and we are going to move that 16, well, it's a -16, so we have to add 16 to the other side, so it's a +16. And now we have x squared is equal to 16. We can take the square root of both sides of the equation, and the square root of x squared, the square and the square root kind of cancel each other out. There's x. And the square root of 16 is 4. So now here's the thing. We've done this problem twice already, and both of the other times we got positive and -4, but here you just got 4. So here's the story when you solve equations by taking the square root of both sides. It is on you to know that when you use this method, you must remember that it's positive and negative of the square root of the right side. It's on you to remember that. So one thing we'll remember, again, is that here I have an x squared. Expect 2 answers. Well, here they are. We know we don't always get 2 answers, but here we do. So we must remember, take the square root, plus and minus 4. Square root of both sides. So it's a quick and easy one. You just have to remember that when you solve equations, and it's only when solving, if you take the square root of 16, it's 4. But you're solving a quadratic equation by taking the square root. So it's plus and minus 4. That's what's happening here. Okay, moving on. Let's check out this example here. So now, I'm only doing this with 2 methods. I'm not factoring it because the only way I'd be able to factor this, 2 sets of parentheses, that has to be a perfect square. Worked great with 16, doesn't work great here because that's 12. So we're going to use the quadratic formula. 1, 0, and negative 12 are my A, B, and C. X equals 0 again, plus and minus the square root of b squared, minus 4 times A, and we'll do parentheses, and negative 12 again. Okay, all over 2A, which is 2 times 1. Slide that up a little bit. And x is equal to, I'm not even going to bother with that 0 in front, but I do have to keep the plus and the minus. Square root. 0 minus 4 times 1 times negative 12. Well, the negative times the negative is positive. You can just type this whole bit into your calculator. 4 times 12 is 48, all over 2. All right, now we got to remember, what's the square root of 48? Well, radical 48, the biggest perfect square that goes in is 16. This is one of the reasons that we did all of that radical work, right? So this is actually 16 times 3. You can take the square root of 16, and that's going to be 4. So it's plus and minus, pull out the 4, radical 3 over 2, reduce these outside numbers, plus and minus 2, radical 3. There it is. These are your 1, 2, 1 positive, 1 negative answers. Let's see what would happen if I'm taking the square root of both sides. Remember, I can only use this method because there's no middle term. There's no linear term, no term with just x. So I'm going to have x squared on the left, add the 12 to the right. I can take the square root of both sides of the equation, and I can really do it also because it's a positive 12. If that were a negative, you can't take the square root of a negative number, remember, so that would be no solution. So here I take the square root and it's x equals, second thing I'm going to know is, hey, whenever I take the square root and I'm solving an equation by taking the square root, it's on me to remember the plus and minus, so I'm not forgetting it this time. Radical 12. All right, radical fans, can you do radical 12 real quick in your head? Well, let's see. 12 is 4 times 3, square root of 4 squared. So plus and minus, I can do the square root of 4, can't do the square root of 3, and that's what x is equal to. And look, they are the same. So we can use this method, and even now, if you're watching this and you like this method, go for it. Only when there's no middle term. Okay, so that's square root of both sides. Here's another method. So this method here, and so I took this quadratic formula because what happens if there is a middle term here? You cannot take the square root of both sides. My go-to would be solve using the quadratic formula. Fine, we did. So I solved and I got this answer so far, but I left it here because I want to continue doing this with you. So now we have negative 6 plus and minus 2 radical 10. So radical 40 simplified to 2 radical 10 all over 2. Remember, when I go to simplify, this denominator can only simplify if it goes into both terms in the numerator. Has to simplify with the term on the left and with this outside number here with that radical term. And it does. 2 goes into this number once, that number once, and that number 3 times. So your final answer would be negative 3 plus and minus, and that's just going to be a radical 10. That's what your x is equal to. All right, we're going to do this method called completing the square, and we're going to see if we get this answer, negative 3 plus and minus radical 10. Okay, completing the square. All right, if we were in school, we would be spending a couple of days on this, so I have to figure out how to do this in 5 minutes. Let's see, x squared plus 6x. I'm going to start us off by doing this. So here's the thing. Here's the word, square. I have to somehow come up with a perfect square, something squared. I want to figure out what my third term here has to be so that I actually have a trinomial that factors into a perfect square, which means that when it factors, I have to have the same exact factor here as I do here. Well, let's take a look. When I start factoring this, I know I'm going to have x here and x here. Fine. I want the same number here and here. Okay, so it could be 1 and 1, 2 and 2. It could be 6 and 6, 10, and 10, I don't know what it is, but I have to find whatever number here works best in this equation. So this is what I'm going to do. I'm going to pretend to multiply it out. So now, if I am factoring, remember, if I am multiplying these two numbers to get some number here, these two numbers have to be multiplied. If it's the same number, it's either a positive times a positive or negative times a negative, and either way, that term is going to be positive. So I know this term is positive because these signs are the same, and this tells you what the signs are. They're both pluses. Let's work backwards. Let's pretend we're going to multiply. X times x, x squared. That's how I get this number. That's this. Now I'm going to distribute over here. Well, that's this number times x. So plus whatever that number is times x. Now I come here and distribute. So that's plus whatever this number is times x. But let's remember that when you combine terms here, you have to get this 6x. So we want to know what numbers should go here, and it has to be the same number. Must be the same number because we want this to be a perfect square. Same number here and here, so you combine and get 6x. Well, I know you're already thinking it's a 3. So that has to be a 3, and that has to be a 3. So let's remember, if you continue doing this, 3 times 3 would give you 9. So x squared plus 6x plus 9, this is what has to be here in order to get these factors, and that means you're going to have an x plus 3 squared. You need to have that perfect square. That's completing the square. Well, the 9 is the number that goes here and completes the square. But here's the story. This, a moment ago, was an equation. These two things were equal, and then we went ahead and added 9 to one side. Well, now they're not equal anymore because this one is bigger. So if we add 9 to the other side, now they are equal again. So let's add 9 to both sides so it stays equal. And of course that equals 10. So now, just like what we did on the other page, we said, oh, well, when we have something squared is equal to a number, I can take the square root of both sides. The square and the radical canceled out, and here's my x plus 3. Oh, and remember that when I solve a quadratic equation by taking the square root of both sides, plus and minus, I got to remember that, that's on me. So plus and minus radical 10, that doesn't simplify, but in the end I am solving for x. The way I solve for x is by moving this 3 to the other side of the equation, not like terms. So I'm going to put that negative 3 first, and the reason why I'm doing that is because this now looks exactly like this. And that's what I got when I solved the equation using the quadratic formula. So using the quadratic formula and completing the square, I do get the same answer. So you could pick your poison. Quadratic formula, it's a formula, plug and chug. This one has a little bit more algebra involved. But that is how to solve an equation by completing the square.